Yeah, enjoying the show? Again, my name's Farr. I'm the V&A and Warehouse Systems Manager for Yale. I'm going to talk to you about three things this morning. We're going to talk about the warehouse storage justification, and these are really some focus things that our department get involved in on a day-to-day basis. We're going to talk about where some of our clients are asking for more help, that being to do with how do I lay out the warehouse, product flow, throughput analysis, simulations, and really becoming more of a consultancy type integrator and partnership, not really replacing the high-end consultants, but just sort of bridging a little gap there. And then we're going to talk about some of the more specialist products that we're being asked to look at and that we've been designing and developing. And it gives a sort of idea as to where people are thinking about for the future. During the presentation, anybody that's got any questions, just if I shout out. If I don't hear you, just wave or something. And feel free to make sure that this is a two-way thing. So, like we said, first thing we're going to talk about, warehouse justification. So let's set a scenario. In this scenario, imagine that we're going to create a warehouse. The warehouse, we want 2,500 pallet locations. That's not an awful lot of pallets. We hear about warehouses having much more, 10,000 pallets or even more than that. So it's a fair size. If we went with a typical storage facility, and we say, what's a typical storage facility? Well, a pallet weighing between a ton, 1.5 ton, not really much more than 1.5 tons, because most wooden pallets can't be stored on a racking system with more than 1.5 ton on them. Most pallets will be 1.2 meters deep, might be 1,000 deep. There's Euro pallets, there's US pallets, 1220 deep by the 42-inch dimension. So, tends to be a stable load. Again, we spoke about 2,500 pallet locations. And let's just, for this example, say that we've got a 6-meter ceiling restriction. So, conventional storage system, we might talk about a 3-wheel or a 4-wheel counterbalance machine. It could be gas, LPG, diesel, or it could be an electric truck. The racking system, we would be looking at just over 4 meters, pallet to pallet, so a clear working aisle. Top beam, in this example, we'll choose 4775, and the reason for that is if we've got a 3-stage triplex counterbalance machine, it's low enough for us to enter the back of a container. So it's suitable for us to use both in racking and also on the docks and general anywhere within a warehouse. So with the 4775 top beam, we can have one pallet on the ground and then 3 stacked up above it. So I think everybody would agree that that would be a typical scenario of how you might configure that type of application. So we would then look at what we call a single command system. And this is whereby normally the way that counterbalance works, a driver would have a pick list and they would have a task. And this task would be perhaps to unload a lorry. Well, they're unloading the lorry, and while they're doing that, they're not doing any other cycles. They're not doing anything other than the unload. If they were to put pallets in racking, again, pallets are one-directional. They're going into the racking. So we call this a single command system. The opposite side of that is what we would call a dual command system. And a dual command system would be a little bit more intelligence behind it, where you might have a radio data terminal. And the radio data terminal would tell the driver to go to point A, pick up a pallet, take it to point B, drop it off, and while you're there, pick up another pallet and take it over to point C. So the truck travels with a pallet more frequently than it would in a single command system. So we tend to see single command systems being associated more with a counterbalance type environment. This type of machine is suitable for loading and unloading trailers. It can work in our racking area that we described as being 4.2 meters clear. It can also be used to enter into perhaps a manufacturing area and drop pallets off in those areas. So it's a bit of an all-rounder, does a lot of different things. Some rule of thumbs that we can associate with it is that typically a counterbalance truck will be traveling 80% of its time and lifting 20%. And in an hour, you could safely say that you can achieve about 12 to 15 pallets per hour as a throughput in a rack system. If you were to draw this new 2,500 pallet location warehouse, in that footprint, actually 66% of your warehouse is required just in aisle space to accommodate that truck. When you look at it from that point of view, that's a huge number. So we're just going to list a couple of those bullet points that we spoke about. So it's a counterbalance truck, gas, LPG, could be electric, 4.2 meter clear aisle. Top beam was 4.7. 1 on the ground, 3 in the air for our stacking. It was a single command system. Can be used to unload load trailers, working in manufacturing areas, delivering, working in the rack. 80% travel, 20% lifting, and an aisle space in a cube utilization scenario being 66% wastage. Well, let's look at the obvious thing of moving to what we would say the reach truck. So we switched to a reach truck model. These are traditionally, obviously, electric. It has a moving mast that reaches out and allows it to have a smaller footprint when operating. When we try to compare that to our previous scenario, our aisle dimension now has been reduced to 2.7. So we're closing our aisle space down. We're going to leave the top being the same and also the stacking. More likely now that with a reach truck type environment, we will be using a dual command system. There might be an integration of a simple handheld barcode scanner, or it may be a truck-mounted radio data terminal, but we're more likely to now see some sort of dual command systems going on. Truck can be used to load and unload in staging areas and in racking. Typically wouldn't be used in a trailer due to the wheels. These type of trucks now, we're looking at 60% of its time traveling and 40% of its time lifting. And again, if we took this footprint area, 51% of that floor space would be wasted by the aisle requirement. So let's take a quick look at what that would look like graphically, and there's an overview of a reach truck application with 2,500 pallet locations. Moving to our last configuration, going very narrow aisle, so this will be a V&A machine. We can reduce the size of the aisle down to typically 1650 as a clear pallet-to-pallet dimension. And again, we run through those bullet points. We're keeping the top beam for consistency at 4775 like we had before. Again, much more likely now to be dual command. More likely to be dual command with some sort of radio data terminal system that also tries to keep the truck in one aisle for a longer period of time. Would also make more use of pick and drop locations at the end of the aisle to ensure that once a machine enters that aisle, it can perhaps do 3 or 4 pallet moves before it needs to exit and move to another aisle. The key point here is that the truck will typically spend 50% of its time traveling and 50% of its time lifting.